Good morning, students. So today we are discussing the last part of the chapter. So yesterday we discussed the spectrum. So that is absorption spectrum and the emission spectrum. So I told you that today I'll show you the diagrams. So here you can see, so continuous spectrum is there, but we don't have that. Just for your understanding, you can see the three pictures and you can understand what is the difference in the continuous spectrum, emission spectrum, and the absorption spectrum. So first figure, what you are seeing, that is the continuous spectrum, and the second one is the emission spectrum, third one is the absorption spectrum. Yes. So in the emission spectrum, you can observe that there is a bright and the dark lines in the background. You can see both the lines, dark and the bright lines, both you are able to see. But when you come to the absorption spectrum, you can see only the dark lines are visible. Only the dark lines are visible. Yes. So here you can see the diagram and you can understand the difference between the emission spectrum and the absorption spectrum. Okay. So this we have covered yesterday. So today we are going to start with the next point, that is the energy level diagram. Here you can see the energy level diagram for the hydrogen atom. Okay, it is for the hydrogen atom. So let us discuss that. Yes. So first we need to understand what do you mean by energy level diagram. Okay. Yes. So here, please keep yourself mute. Yes. So what is energy level diagram here? Energy level diagram is nothing but, yes, it is a diagram in which the horizontal line, so here you can see the horizontal line also, and you are able to see the vertical lines also. So these are the vertical lines and these are the horizontal lines. So you are able to see both the vertical and the horizontal lines, which represents the energy levels, and the vertical lines represents transition of electrons from higher energy level to the lower energy level. So here, whatever the diagram you are observing, this is the energy level diagram for the hydrogen atom. Here the vertical lines you are seeing, that is nothing but the energy levels, and the horizontal lines are what? It is the electron transition you are able to see. It is the electron transitions. So the energies of electrons in different orbits are calculated. So how you can calculate the energy of the different orbits? We know already the formula for the energy, that is given by minus 13.6 divided by n square electron volt, where n is equal to 1, 2, 3, 4, so on up to infinity. So this is the formula for what? That is the energy level diagram. Okay, for the hydrogen atom. So whatever the formula you are able to see here, students, this formula is for the hydrogen atom itself. So based on the, means which orbit is there. So n value you can substitute, means whether it is a ground state or whether it is a first, second, with respect to that you can substitute the values here. So if it is a ground state, you will get n is equal to 1. Okay. So now let us come to the energy level, because ವರ್ಟಿಕಲ್ ಲೈನ್ಸ್ ಏನ್ ಹೇಳ್ತಾ ಇದೆ, ಇಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಆರ್ಬಿಟ್ ಇಂದ ಯಾವ ಆರ್ಬಿಟಿಗೆ ಟ್ರಾನ್ಸಿಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ. ವರ್ಟಿಕಲ್ ಲೈನ್ಸ್ ನಿಮ್ಗೆ ಏನ್ ಹೇಳ್ತಾ ಇದೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ವರ್ಟಿಕಲ್ ಲೈನ್ ಇಸ್ ಟೆಲಿಂಗ್ ಯು ಅಬೌಟ್ ದಿ, that is it is representing the electrons transitions. It is representing electron transition. So here you can see the Lyman series. So Lyman series is there, Balmer is there. Yes, in the Lyman series, that is n is equal to 1. Here you can see that is representing n is equal to 1. When this n is equal to 1, what is the energy value? It is 13 point minus 13.6. Suppose if you substitute n is equal to 2, That is here second level. So here n is equal to 2 means the energy becomes minus 3.4. Suppose if you substitute n is equal to 3, it is becoming minus 1.5. Suppose n is equal to, you are substituting n is equal to 4, then it is minus 0.85. ಇದೇ ರೀತಿಯಾಗಿ n is equal to value ಹಾಕ್ತಾ ಹೋದಾಗೆ ನಿಮಗೆ values ಇಲ್ಲಿ ಬರ್ತಾ ಹೋಗುತ್ತೆ. So this is for the Lyman series. Balmer series. Next passion ಗೆ ಬರ್ತಾ ಇದೆ. After that, when you are substituting n is equal to 4, ಯಾವ್ದು ಬರುತ್ತೆ ಹೇಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್? If it is n is equal to 4.
Bracket.
Yes, it is bracket series. Then last one is the P fund series. Yes, yesterday we have discussed this one. So that is not represented here. So if you want, we can show it. So here we can show the first line for the bracket series. So here the first line. Then this is second. ಇದೇ ರೀತಿಯಾಗಿ next. So when you substitute n is equal to 5, it is P fund. So this is the first and this is the second line. So energy values also we have substituted. This is energy level diagram representation. Sometimes 2 marks al barutte. So energy level diagram. What is energy level diagram? Write the energy level diagram for the hydrogen atom. So first you have to explain what is energy level diagram. Energy level diagram and it is a diagram which consists of horizontal lines and the vertical lines. Horizontal lines are representing the energy levels and the vertical lines are representing that is the electron transition. It is representing electron transitions. Yes. So first one definition. Then energy is given by, it is E is equal to minus 13.6 divided by n square electron volt. Then after that, here n is equal to 1, Lyman series, Balmer series, Passion, bracket and the P fund series, all you need to represent here. Okay, so this is regarding the energy level diagram here, students. So remember the formula, which is very, very important. Okay, yesterday already we have discussed about this, where it is. That is the spectral lines. So the series we have discussed, all the 5 series we have discussed. So based on this, today we are discussing some questions also. Okay, so here first some points you remember. Suppose if they are saying it is first excited state. Okay, so our question ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, it is the first excited, ground state ಅಂತ ಹೇಳಿದ್ರೆ, that time you have to consider n is equal to 1. That time you have to take n is equal to 1. Suppose energy calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರೆ, energy is equal to minus 13.6 divided by n square, ಅದೆಷ್ಟು ಬರುತ್ತೆ? minus 13.6 ಅನ್ನೇ ಬರುತ್ತೆ in the electron volt. Suppose if they are saying the first excited state. So first excited state and n is equal to 2. So that is E1 is equal to E2 is equal to, it is minus 13.6 divided by 2 square, which is equal to minus 3.4 electron volt. Suppose the second excited state. So second excited state and then even matira gadbadiyalli you will take here 2. It is not 2, it is 3. So second excited state means it is n is equal to 3. So substitute n is equal to value and E3 value will be minus 1.51 electron volt. The third excited state n is equal to 4 and the value comes out to be that is minus 0.85. So if you are able to remember these values, it is very good. Okay. Otherwise every time calculate ಮಾಡ್ತಾ ಇರಬೇಕಾಗುತ್ತೆ. So for the last excited state, can anyone tell me what is the value of n for the last excited state? What is your n value? If you know what is the n value, you can understand the value of energy. It is n is equal to last excited state. Because your n can take the value from 1 to up to what? N can take the value from 1 to, yes? It is yes, up to infinity we can take. N is equal to 1, 2, 3, up to infinity we can take. So ಹಾಗಾಗಿ last excited state ಅಂತ ಹೇಳಿದ್ರೆ, you can take n is equal to infinity, students. ಹಾಗಾದ್ರೆ energy ಎಷ್ಟಾಗುತ್ತೆ? What will be your energy? The formula is minus 13.6 divided by n square. So n is equal to infinity. Hagadre E value. What is the value of E? Any value is better. It is any value divided by infinity is nothing but what? It is 0. Okay, suppose if you have minus 13.6 divided by infinity, which is equal to 0. Suppose you minus 13.6 divided by 0 tagondre infinity agatte. It is reverse. Yes. Is it clear? So ground state n is equal to 1. So ಇಲ್ಲಿ you mistake ಮಾಡೋ chances ಇರುತ್ತೆ students. Ground state, please take it as n is equal to 1. First excited state n is equal to 2. Second excited state n is equal to 3. Last excited state is n is equal to infinity. Therefore, the energy will be 0. Okay. So remember this one. Okay. So already we have discussed about the merits and the demerits of that is Bohr's atomic model. So in the last class already it is completed. If you want, just we will revise it once and we will go for the next point. Yes. So according to Bohr here, what are the merits? So Rutherford could not explain the spectrum, but Bohr will successfully explain that. So because of that, he can predict the size of the atom. So size of the atom was successfully determined by the Bohr, and the second explanation is he explains the stability size ಬಗ್ಗೆ ಹೇಳ್ತಾರೆ, stability of the atom ಬಗ್ಗೆ explain ಮಾಡ್ತಾರೆ. This theory explains origin of the spectral lines. So spectral lines origin ಬಗ್ಗೆ explain ಮಾಡ್ತಾರೆ. Therefore this is the third merit. The fourth is Rydberg constant value also it is calculated by using the that is Bohr's theory. The ionization energy of the hydrogen atom in the ground state. So ionization energy kuda using Bohr's theory we can calculate. So size, stability, spectral lines, Rydberg constant, energy of the hydrogen atom in the ground state is calculated by using this Bohr's theory. These are the merits points. So in the notes I'll upload this. You can copy that time. What about the limitations or the demerits here? So it is applicable only for the hydrogen and hydrogen-like atoms. It is applicable only for the hydrogen and hydrogen-like atoms anta ಹೇಳ್ತಾರೆ ಆಯ್ತಾ. And it could not explain the fine structure. It could not explain the fine structure of spectral lines. Fine structure of spectral lines. It could not explain relative intensity of the spectral lines. So fine structure of the spectral lines, relative intensity of the spectral lines, that could not be explained by the Bohr. And the next Stark effect and the Zeeman effect also could not be explained by the Bohr. He could not explain the wave nature of the electron. He could not explain the wave nature of electron. So these are the demerits or the limitations of Bohr's atomic theory, which we have already discussed in the last class. Just I have revised it. So now we can go for that is numericals. So we have seen the radius formula nodidvi, energy formula nodidvi, wavelength formula discuss madidvi. So based on that we can see some of the questions today and tomorrow to understand the lesson very nicely. So now if you have any doubt in the lesson you can ask, otherwise I am sharing you the questions now. So just confirm whether the questions are visible or no. I think it is not visible. Once again. Okay, I'll share the screen. Okay, if any doubt is there from your side from the lesson, you can ask. Now we are moving towards the questions. Hope so you have all the formulas. Okay, I'll start with the questions. Just a minute, I'm sharing the screen. Question is visible, students? This question is visible. Okay, let us start with the questions now. So the first question is, what is the shortest wavelength present in the Passion series of the spectral lines? So question looks very simple. Formula kuda niಮಗೆ ಗೊತ್ತಿರುತ್ತೆ, but there is a chance we will do the mistake. So let us see. So see, what is the question? What is the shortest wavelength present in the Passion series of spectral lines? Okay. So for the Passion series, what is the shortest wavelength anta helidare? So yesterday I told you for the shortest wavelength and for the longest wavelength, what values you have to consider. So N1 is equal to ಏನ್ change ಆಗಲ್ಲ, passion. So Lyman Balmer passion is the third one. So N1 is equal to 3 ಆಗತ್ತೆ. And N2 is equal to, it will be infinity. N2 is equal to infinity. N1 is 3, N2 is equal to infinity. So the formula is what? 1 upon lambda is equal to R into bracket 1 divided by N1 square minus 1 divided by N2 square. Okay. So here we can substitute R and here we can substitute the value of N1 and N2. So 1 upon N1 square is 1 upon 3 square is 9 minus 1 upon infinity is 0. So leave that. So it is R divided by 9, right? So this is nothing but R divided by 9. Or if you want the shortest wavelength, it will be what? Lambda is equal to ಏನಾಗುತ್ತೆ 9 divided by R. It will be 9 divided by R. So therefore, this is equal to 9 divided by, what is the value of R? The Rydberg constant, 1.097 into 10 to the power of 7. So simplify ಮಾಡಿ, you will get the answer. Nine divided by 1.09. You can tell me the answer after doing the calculation. Copy down the steps and tell me the final answer. To simplify 9 divided by 1 point, yes, it is 8.204 into 10 to the power of minus 7. So if you want to write it in terms of angstrom, you can transfer the decimal also. 8.24204 into 10 raised to minus 7. So if I shift the decimal, angstrom andre 10 raised to minus 10 ಬರಬೇಕಾಗತ್ತೆ. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ 1, 2, 3. Therefore, it is 8204.1 angstrom. Correct? So this is the wavelength for the Passion series. Yes. So here, students, when you are doing any numerical, you need to understand here what is the concept. See, ಏನ್ ನೆನ್ಪಿಡ್ಬೇಕು ಇಲ್ಲಿ shortest wavelength ಅಂತ ಹೇಳಿದರೆ. So shortest wavelength ಅಂದ್ರೆ N2 is equal to infinity ಬರುತ್ತೆ. Whether they are asking for the Lyman series, Balmer series, Passion bracket ಯಾವುದೇ series ಕೇಳಿ N2 is equal to infinity. What about N1? N1 value you know how to substitute, because N1 is what? It is with respect to whatever the series we are taking. So Lyman idre 1, Lyman Balmer 2, Passion 3, bracket 4, and last one P fund is 5. So N1 value you can take it accordingly. N2 value shortest wavelength ಯಾವುದು ಬೇಕಾದ್ರೂ ಇರ್ಲಿ ಯಾವ series ಗಾದ್ರೂ N2 is equal to infinity ಆಗತ್ತೆ. Just substitute to the values here and calculate the value of lambda. And we know the no, not compulsory to convert in angstrom. So why I'm telling you conversion, because sometimes in the MCQs you will get such type of questions. So they may not give you in terms of power, they may give you just like angstrom athwa 10 raised to minus 6, that is micro dal kodbodu, like that conversions you should know stay. So if you are stopping at 10 raised to minus 7, write the unit as meter. If you are stopping the last step in terms of means if you are writing it in terms of angstrom, you can write it lastly. Anything is fine. Yes, is it clear everyone? Artha aita elrigu? So if this is okay, so let us go for the next question. Yes, next question, students. A difference of 2.3 electron volt separates two energy levels in an atom. What is the frequency of radiation emitted when the atom make a transition from the upper level to the lower level? So the atom is making a transition from upper level to the lower level. So here the energy difference is given as what? 2.3 electron volt. So what you need to calculate, what is the frequency anta kelidare. So frequency value anna find out ಮಾಡಬೇಕಾಗಿದೆ. What is the frequency value? Let us calculate. Okay. So here the frequency is given by what? We have E is equal to H nu. So therefore nu is equal to frequency, that is nothing but E upon H. So E is what? E is the energy which they have given it as what? That is 2.3 electron volt. So the 2.3, whether we have to convert in joules or we can use it as it is. Because the Planck's constant is, it is 6.63 into 10 to the power of minus 34 joules. So idu joules al baratte. What about the energy? We have to convert it or keep it as it is. Yes, we have completed so many numerical students. You should answer these type of questions now. Yes, whether we need to convert. Yes, conversion is required because denominator term joules alide. Numerator also it should be in the same unit. So convert in electron volt to joules. The conversion factor is 1.6 into 10 to the power of minus 19. So convert to joules ಮಾಡಬೇಕಾದ್ರೆ multiply ಮಾಡಬೇಕಾಗುತ್ತೆ. Convert to electron volt ಮಾಡಬೇಕಾದ್ರೆ divide ಮಾಡಬೇಕಾಗುತ್ತೆ. In the dual nature I told you already. Yes, 2.3 into 1.6 divided by this and the power. So you can go for the simplification step. Yes, so Bhagya, your answer is right. That is, or else decimal, you are getting 0.5555. Yes, any power you are getting or no? Power is there? 10 to the power anything you are getting or no?
10 to the power of 19, ma'am.
10 to the power of 19. Okay, fine, no problem. So if you convert that 10 to the power of 19, if I shift the decimal, I can also write it as, so 5 point, 0.5555 ತರ ಬರ್ತಾ ಇದೆ. So ನಾನೇನ್ ಮಾಡ್ಬೋದು ಅಂತಂದ್ರೆ, according to the rounding up the figures, we can make it as what? 5.6 also I can make it. So ಇದನ್ 5.6, if you shift that, ಅಂದ್ರೆ 0.555 ಅಂತ ಇದೆ. So into 10 raised to 19 ಅಂದ್ರೆ 1, 2, 3, 4. So 1, 2, 3. So if I transfer the decimal, I can also write it as, that is 5.6 into 10 to the power of 14 hertz ಅಂತ ಬರ್ಬೇಕು ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್. So see, check everyone your decimals, you can check it. Yes, baby, correct, no problem. That is 0.5550 into 10 raised to 15. Just one decimal ಅನ್ನ shift ಮಾಡ್ಕೊಂಡ್ರೆ ಅಲ್ಲಿ 10 raised to 14 ಆಗತ್ತೆ, no problem. So it is frequency, students. So frequency anta andaga it should be, the unit is what? That is hertz. So frequency is equal to 5.6, approximately 5.6 or 5.5. No problem. Any value is fine. Hope so it is clear to everyone.
Yes, ma'am.
Okay. So yarig gottilla, just make a list of these constant values. The Planck's constant is given by 6.63 into 10 to the power of minus 34 joule second. So the Planck's constant is 6.63 into 10 raised to minus 34 joule second. Sometimes we require the velocity of light in vacuum. So take the velocity of light in vacuum is what? That is 3 into 10 raised to 8 meter per second. Similarly, the mass of the electron is, it is 9.1 into 10 to the power of minus 31 kg. That is 9.1 into 10 raised to minus 31 kg. Similarly, the charge of the electron, if we write, it is 1.6 into 10 raised to minus 19 coulomb. And the Rydberg constant R is equal to, the Rydberg constant R is equal to 1.097 into 10 to the power of 7 plus 7 per meter. So you just remember epsilon naught. Very rarely we may require this, but remember 8.854 into 10 to the power of minus 12 Fermi per meter. Okay, and 1 joule to electron volt conversion is 1 joule is equal to 1 divided by 1.6 into 10 raised to minus 19 electron volt. That is 1 joule to electron volt conversion. Yes, copy down the values. We can go for the next question. Yes, the next question, students. The ground state energy of hydrogen atom is minus 13.6 electron volt. What are the kinetic energy and potential energies of the electron in this state? Yes, the ground state energy of hydrogen atom is minus 13.6 electron volt. What are the kinetic and potential energies of the electron in this state? So you know the relation between kinetic energy, potential energy, total energy. So here the ground state energy of hydrogen atom is given as minus 13.6. So the energy is minus 13.6 electron volt. What is the kinetic energy and the potential energy of this electron? Okay, so we know that the kinetic energy is equal to, it is minus of the total energy. The kinetic energy is equal to minus of the total energy. So which is equal to minus into bracket. So what is the energy value they have given? It is minus 13.6. Yes. So here what we are writing, this is minus of E. So minus keep as it is. Energy value is what? Minus 13.6. So minus into minus, it becomes plus. Therefore, it is plus 13.6 electron volt. This is the value of the kinetic energy. This is the value of kinetic energy. Okay. So what about the potential energy here, students? The potential energy is what? It is the minus of twice of the kinetic energy. So which is equal to minus 2 into kinetic energy is how much? It is 13.6. So 13.6 into 2 is how much? It is 27.2, and plus into minus is minus. Therefore, it is minus 27.2 electron volt. So they are asking you both the kinetic energy and the potential energy. So kinetic energy is plus 13.6 electron volt and the potential energy is minus 27.2 electron volt. So ನಾನು ನಿಮಗೆ ಥಿಯರಿ ಹೇಳಬೇಕಾದ್ರೆ ಹೇಳಿದ್ದೆ that total energy and kinetic energy relation. So the kinetic energy is minus of the total energy. ಮತ್ತೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅನ್ನೋದೇನಿದೆ ಮೈನಸ್ ಆಫ್ 2 ಟೈಮ್ಸ್ ಆಫ್ ದಿ kinetic energy. We have discussed this already. If you want, you can write it now. Yes. Yes, copy down. If completed, please tell in the chat box. I'll go for the next question. Okay, everyone, let us go for the next question. Maybe the last question for today's class. Let's see how much time it will take. Okay, so here is the question. The radius of the innermost electron orbit of the hydrogen atom is 5.3 into 10 raised to minus 7 meter. What are the radii of the n is equal to 2 and n is equal to 3 orbits? Yes, what they are saying. See, the radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 raised to minus 11 meter. What are the radii of the n is equal to 2 and n is equal to 3 orbit? Okay, so hope you remember we have discussed the radius is equal to formula Rn is equal to, it is epsilon naught n square h square upon pi m into z into e square. So here they are giving you as a hydrogen atom. So hydrogen atom irodrinda enagutte, that is epsilon naught n square h square divided by pi m z is equal to 1 agutte. So the formula becomes epsilon naught n square h square upon pi m e square. Okay. So we also know that here whatever the values are there except n anna bittu epsilon naught constant ide h pi m e ella constant irodrinda, so we have substituted and calculated the values n square, keep it as it is. Idella enide, that is all constant here. So its value is 5.3 into 10 to the power of minus 11. 5.3 into 10 to the power of minus 11. Okay, so ಇದೇನ್ ಬಂತೀಗ Rn is equal to ನಮ್ ಫಾರ್ಮುಲಾ ಬಂದಿದೆ. ಸೊ ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಫಾರ್ n is equal to 2 and n is equal to 3 ಗೆ ರೇಡಿಯಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ. ಸೊ ನಮ್ಗೆ ಈಗ ಫಾರ್ಮುಲಾ ಗೊತ್ತಾಯ್ತು. ಹಾಗಾದ್ರೆ ನಾನು ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, R2 is equal to, it is 2 square into 5.3 into 10 raised to minus 11 ಒಂದಾಯ್ತು, and R3 is equal to, it is 3 square into 5.3 into 10 raised to minus 11. So just write the answer over. So in exam no need to do all these things, just write the formula and the constant value and go ahead. 21.2. So if it is, if you are writing in same power, it is 21.2, no problem. Again, if I want to make it in angstrom, I can also write it as what? That is 2.12 into 10 raised to minus 10 meter. Or else 10 raised to minus 10 meter but bitre angstrom anta bariyadu. And the other one is 5.3 into 10 raised to, sorry, it is 5.3 multiply madam is 4.77 into 10 raised to minus 10 meter, or else 47.7. Yes. Is it clear, everyone? One more question we will see. Let's copy down. We will go for one more last question. Okay, hope so everyone completed this. Yes, the next question is, so take down the question here. What is the, so 4 question. This is the 5th question. The next question is, what is the distance of closest approach? What is the distance of closest approach when a 5 mega electron volt, when a 5 mega electron volt proton approaches, when a 5 electron volt proton approaches a gold nucleus, a gold nucleus. So in bracket, they have given the value of Z is equal to, that is 79. It is given as Z is equal to 79. Yes. So here they are asking you to calculate. See, what is the distance of closest approach when a 5 mega electron volt proton approaches a gold nucleus? So distance of closest approach is nothing but what? You have to calculate the value of R. So already we have discussed while discussing the definition of the distance of closest approach is nothing but the distance of closest approach is the kinetic energy of the proton is equal to potential energy of the proton and the gold nucleus of the gold nucleus. So therefore navige ಏನು ಮಾಡಬಹುದು ಅಂತ ಅಂದ್ರೆ, so you can write the question. I'll give you the hint here, students. That is, the energy is equal to, it is 1 upon 4 pi epsilon naught Z E square upon R naught. So Z E square is, that is Z E is for the nucleus into E. So ಹಾಗಾಗಿ Z E square ಆಗುತ್ತೆ. So you can calculate the R naught value. So R naught value is equal to ಏನಾಗುತ್ತೆ? It will be 1 upon 4 pi epsilon naught Z E square upon the kinetic energy. Z E square upon the kinetic energy. Yes. What is 1 upon 4 pi epsilon naught? We know that 1 upon 4 pi epsilon naught is what? 9 into 10 raised to 9 into Z E square. So Z E square is nothing but what? So Z value is, they have given, it is 79 into E value, the charge of the electron, 1.6 into 10 raised to minus 19, it's a square, upon kinetic energy. They have given it as what? 5 mega electron volt. So 5 into mega, if you convert, it will be 10 raised to plus 6 into electron volt to joules. It is 1.6 into 10 raised to minus 19. I'll repeat here, students. So they are asking you to calculate the distance of closest approach. So to calculate that, we have the formula 1 upon 4 pi epsilon naught Z E square upon R naught. So that is R naught is equal to 1 upon 4 pi epsilon naught Z E square upon kinetic energy. 1 upon 4 pi epsilon naught 9 into 10 raised to 9. Z value is 79. E value is 1.6 into 10 raised to minus 19 whole square. And divided by kinetic energy, ಅವರು ಕೊಟ್ಟಿದ್ದಷ್ಟು 5 mega electron volt. So 5 mega electron convert ಮಾಡಿದ್ರೆ it is 10 raised to 6. Electron volts to joule, it is 1.6 into 10 raised to minus 19. You can do with the calculation part, students. So do the calculation, tell me the value of R naught. Keep it in terms of 10 to the power of minus 14 tagoli. Answer you tell me in terms of 10 to the power of minus 14. So that you only do the arrangements of the power, decimals. So 2.27 is correct, or else 2.28 is correct. So the answer is 2.28 or 2.27 into 10 raised to minus 14 meter. Okay, students. So carry on with the calculation. Practice the formulas today. Tomorrow we will continue with few more questions. Okay, thank you. Bye.
Thank you, ma'am.